Hi, my name is Melanie Schoers, a graduate student in the School of Meteorology at the University of Oklahoma. In this video, I will introduce the sub-seasonal to seasonal timescale that bridges weather and climate. In the past, there have been two main types of meteorological timescales used for prediction and projections: weather and climate. Weather prediction involves forecasts of daily weather patterns up to 2 weeks in advance, similar to what you may see on your local news or weather apps. On the other hand, climate involves the slowly evolving atmospheric, oceanic, and land fluctuations across seasons or beyond. For example, climate information is used in seasonal outlooks to indicate whether temperatures will be above or below average for the next few seasons. When we want to look at longer-term trends, we use global climate models that incorporate greenhouse gas emissions to create climate projections, which can show us how temperature and precipitation, for example, may change out to the end of the 21st century. The gap between these two forecasting periods is what we call the subseasonal to seasonal timescale, otherwise known as S2S. Forecasts on the S2S timescale are for the next 2 weeks to approximately 2 to 3 months. Typically, these forecasts will not be as specific as what you see in daily forecasts, but will offer more information than those made for climate timescales. This period is critical for decision makers, especially for the timing and impacts of extreme events. The need to forecast these events will only become more important as weather extremes continue to be amplified by climate change. The S2S timescale has been historically difficult to predict. It is too long to retain important information about the current conditions of the atmosphere and weather pattern changes, such as the movement of low and high pressure systems that can create temperature changes or storm systems. But it is also too short to make use of boundary conditions like changes in the composition of our atmosphere due to increasing greenhouse gases and other long timescale processes, such as sea surface temperature changes or feedbacks from the land surface. This divide between short and long-term processes creates a need to find better sources of predictability that may exist within the S2S timescale. Recent research has led to the discovery of multiple sources of predictability on the S2S timescale, such as the location of precipitation in the tropics, changes in the strength of the stratospheric polar vortex, and snow cover. With the help of technological advances and the discovery of these multiple sources of S2S predictability, there's now the capability to generate skillful and useful S2S forecasts using both weather and climate information. Although S2S forecasts will not be able to predict the exact timing, location, and magnitude of an extreme weather event multiple weeks in advance, it may be possible to predict how likely such an event will be over a particular region 2 weeks to 3 months in advance. We have also learned from decision makers that there's an increasing need for better early detection of high-impact weather periods that may have a large societal impact. One way to try to achieve earlier detection is to focus on forecasts of opportunity, which is when the presence of certain atmospheric or oceanic conditions can result in an increased likelihood of extreme weather at a later date, for example, on subseasonal timescales. Let's look at the February 2021 Great Plains cold wave as an example of how S2S forecast could be implemented. During this event, extremely low temperatures and associated winter storms led to numerous fatalities, travel chaos, and widespread infrastructural damage, including the near blackout of the Texas power grid. Prior to this event, there was a featured forecast that signaled an extreme event occurrence was possible at the S2S lead time. Although the cold wave was well forecasted on shorter timescales, a well-utilized S2S forecast could have helped to reduce many of these impacts. Another example of a potential S2S forecast application is the persistent precipitation event along the west coast of the United States, starting in the last week of December 2022, that lasted 3 weeks. This event led to numerous fatalities, vast power outages, and infrastructural damage due to landslides. While individual days during this event were well forecasted, decision makers would have benefited from an S2S forecast showing increased probability of high precipitation that spanned the 3-week period. To prepare and mitigate the impacts of such disasters, the Red Cross Red Crescent Climate Center has developed the Ready, Set, Go framework to use weather, S2S, and seasonal forecasts. Ready involves using seasonal forecasts to begin monitoring potential weather events, train volunteers, and create contingency plans. During Set, decision makers use S2S forecasts to gather volunteers and start communicating risk to the communities affected. Finally, with Go, decision makers use weather forecasts to make decisions regarding community evacuations, volunteer activation, and distribution of specific risk information. This initiative is the starting point for future seamless predictions that will bridge the gap between weather and climate forecasting.